Hi, in this video we are going to discuss the existence problem in the Fourier transform. That is, given a function x of t, can we claim that its Fourier transform exists? Or under which conditions can we claim that the Fourier transform exists? So now we know that we have the Fourier transform pair, okay, provided that the Fourier transform exists, x of t and capital X of omega. Okay, so we ask the following question. Can we claim that x of omega exists for any arbitrary x of t? Okay, so this is, of course, an important question. The answer to this question is negative. That means the answer is no. Therefore, we have to specify certain conditions on x of t such that the Fourier transform exists. Now, existence of the Fourier transform means that x of omega, if we consider the magnitude of x of omega, magnitude of x of omega must be finite for all omega. For the existence of x of omega, we must be sure that magnitude of x of omega, remember x of omega is in general complex valued, so magnitude of x of omega means modulus of x of omega. This must be finite for all omega between minus infinity and plus infinity. Okay, that means this condition is shown symbolically by this inequality. X of omega must be finite or less than infinity for all omega between minus infinity and plus infinity. Okay, now if we look at magnitude of x of omega, this is equal to magnitude of the Fourier integral from minus infinity to plus infinity, x of t e to minus j omega t integrated with respect to t. So this integral or magnitude of this integral must be finite for all omega between minus infinity and plus infinity. Okay, now we can consider this quantity, magnitude of the integral is less than or equal to the integral of the magnitude of the integral. Magnitude of the integrand is magnitude of x of t, magnitude of e to minus j omega t, integrated with respect to t. Okay, now we know that magnitude of e to minus j omega t is always equal to 1, because for any omega, this expression is cosine omega t minus j sine omega t. So cosine square omega t plus sine square omega t square root is 1. Therefore, the condition for the existence of the Fourier transform is that for the existence of x of omega, the following condition must be satisfied, which is from minus infinity to plus infinity, magnitude of x of t integrated with respect to t must be finite. In other words, x of t must be absolutely integrable. Now, if x of t is real valued, magnitude is the absolute value. If it is complex valued, magnitude is the modulus. So, in other words, x of omega, which is the Fourier transform of x of t, exists if x of t is absolutely integrable. Okay, so in order to be able to claim that the Fourier transform of x of t exists, x of t must be absolutely integrable. Okay, now in some examples, we are going to see cases where we are able to evaluate the Fourier transform, and also some cases where we are not able to evaluate the Fourier transform. That means the Fourier transform may not exist for certain signals. So let us now continue discussing this problem in terms of some examples. Okay, let us start with the following example. X of t is equal to e to minus t u of t. Okay. Now, can we claim that the Fourier transform exists? Now, we look at the condition of absolute integrability of x of t. Okay, so from minus infinity to plus infinity, magnitude of x of t integrated with respect to t is, now the signal x of t is 0 for negative values of t, so the integral will start from 0 to infinity, and we have e to minus t. The magnitude is e to minus t, because e to minus t for all values of t is non-negative, integrated with respect to t. Okay, so this is minus e to minus t evaluated at 0 and infinity. Now the important point here is that at the integration limit t tending to infinity, e to minus t decays to 0. So this can be written as follows in more correct terminology. Limit as t tends to infinity minus e to minus t, and then we have e to minus t evaluated as 0 is 1. Okay, so we have 1 over here, and as you see, this term is 0. Okay, so x of t is absolutely integrable. And therefore x of omega exists. In fact, x of omega is from minus infinity to plus infinity. X of t, which is e to minus t u of t, e to minus j omega t, integrated with respect to t. So this is from 0 to infinity, e to minus, we can combine these two exponential functions, the product of e to minus t and e to minus j omega t, e to minus 1 plus j omega t integrated with respect to t. So this becomes minus 1 over 1 plus j omega e to minus 1 plus j omega t evaluated at 0 and infinity. And again here we see the importance of absolute integrability of the original signal, because we have the signal present within this expression as e to minus t, and as t tends to infinity, that will be 0. It will decay to 0, and the result of the Fourier transform is 1 over 1 plus j omega. So the Fourier transform of e to minus t u of t is 1 over 1 plus j omega. Okay, so here we see that an absolutely integrable signal will have a Fourier transform, and we are able to calculate the Fourier transform. Now, let us look at the next example. So maybe we can call the first example as example 1. Now we have example 2. X of t is equal to e to t u of t. Now, what can we say about the Fourier transform of x of t? Can we evaluate the Fourier transform of x of t? Or in other words, can we claim that the Fourier transform exists? Now we check the condition of absolute integrability from minus infinity to plus infinity, magnitude of x of t integrated with respect to t. So from 0 to infinity, e to t integrated with respect to t, which is written as e to t evaluated at 0 and infinity, or limit as t tends to infinity e to t minus 1. But as you see, this limit is not finite, so we have a diverging expression. Therefore, the signal is not absolutely integrable. Okay? So x of t is not absolutely integrable. Therefore, x of omega does not exist. Okay. So, we have seen two examples. In example 1, the signal is absolutely integrable and its Fourier transform exists. In example 2, the signal is not absolutely integrable and we are not able to find or evaluate its Fourier transform. The Fourier transform does not exist. Okay, so we can stop at this point. Thanks for watching.